Welcome to this video. My name is Mark Scythian. The date today is May 21st, 2023. So you may be working with test questions such as these. Convert the decimal value 217 to its binary value and convert the binary values 10, 0, 1, and 10, 10, 1101 to their decimal values. So the first step is to establish a base 2 logarithm binary chart, and this is up to 8 digits. Usually a chart like this will be on your exam as a reference. So from this point forward, we can start with A, and we have to convert 217 to its binary value. So the first step is to choose the largest value at the 2 to the 7th power switch. So we're going to turn this on, and then this just leaves us with 89 left to convert. So 217 minus 128 is 89. So 64 is smaller than 89, so we can turn on 2 to the 6th power switch. Then this leaves us with 89 minus 64, which is 25. So we notice that 2 to the 5th power, 32, is larger than 25. So we are going to turn this 2 to the 5th power switch off. So next, we look at 2 to the 4th power. This digit switch, it's 16 decimal value, 2 to the 4th power. So this is less than 25. So we will turn on 2 to the 4th power. So we get 25 minus 16. This is 9. So the next switch, 2 to the 3rd power, 8 is less than 9. So we can definitely turn 2 to the 3rd power switch on. So this leaves us with 9 minus 8, so 1. So 2 to the 2nd power, 4 is too large, so we will turn off 2 to the 2nd power. And 2 is too large, so we keep this one off as well. So all we have left is 1, so we turn 1 on, so 2 to the 0th power. So 1 minus 1 equals none remaining. So we have completed the conversion of 217 to its binary value of 1101, 1001. So we can write that in here. 1101, 1001. So working on the second part of the question is pretty straightforward, because all we have to do is basically turn on the indicated binary function. So 1 represents on and 0 represents off. So if we allocate the digit selection for part B, we start from always the right side of, in this case, less than 8-digit binary value. And so we go to the right side and enter in 1 for 2 to the 0th power, and then 0, 0, and 1. So we're turning on 2 to the 0th power. We're keeping 2 to the 1st power off, 2 to the 2nd power off, and 2 to the 3rd power on. So this translates to 8 plus 0 plus 0 plus 1. So the binary value 10, 0, 1 is equal to 9. And then if we repeat the process once again, we start from the right side or at 2 to the 0th power. So we enter 1, 0, 1, 1, 0, 1, 0, 1. So this is on for 2 to the 7th power, off for 2 to the 6th power, on for 2 to the 5th power, off for 2 to the 4th power, on 2 to the 3rd power, on 2 to the 2nd power, and then we have off for 2 to the 1st power and on for 2 to the 0th power. So if we calculate the on switch on the transistor switching system or the base 2 logarithm binary calculation here, we have 128 plus 0 plus 32 plus 0 plus 8 plus 4 plus 0 plus 1. So if we add up 128, 32, 8, 4, 1, we get the value 173. So for 10, 10, 11, 0, 1, we get the decimal value of 173.